Hi YouTube, welcome to MA Academy C++ Data Structures tutorial series. Now in the previous tutorial I showed you guys how to create a very simple and basic linked list. However, as I mentioned in that tutorial, it was not a very efficient or effective way of creating a linked list. However, I did it so just I could explain to you guys in a better way what a linked list is, how it works, and things like that. So in this tutorial, I will show you guys how to create a function that will keep adding new nodes into the linked list. So as you call this function, it will keep adding a new node to the end of the linked list. So let's get started. By the way, I have created this website called www.maacademytutorials.com. I will upload more and more tutorials to it regarding C, C++, Python, etc. So if you're interested, feel free to visit it. Now this is the program with which we will be working in this tutorial. Now I've already created or written this program in here because I just didn't want to waste a couple minutes typing it and things like that. So I think I try to keep the videos short. So I thought it would be faster if I just type it and then I explain it. So in here, again, if you haven't watched if you don't know what a linked list is, or if you don't understand it very well, please watch my previous tutorial because because if you don't, then much of this tutorial won't make much of sense to you. So in here, the first thing I'm doing is that I'm creating a structure and I'm calling it node. So this structure has two parts or two sections, or there are two data elements inside it. The first one is an integer, we call it data, and then there is a pointer which will point to the node. So we can see that this next is of type struct node. So this pointer will point to a node. So this is how linked lists work, in case you don't know. So a node will point to the next node. So we do that with the help of a pointer that is of type the struct node, which is the same as this one in here. Again, you can add more data elements to it if you want. I'm just using data, so if you wanted to do something like car, C, or something like let's say float, num, things like that, you could do it. But for simplicity's sake, I'm just using a data. Next, I create another pointer, and this time I'm calling it first. So at first, this is not pointing to anything; it's pointing to null. So this is I will create this so that it will point to the first node inside the element, inside the linked list. Sorry. So this is the function with which we will be working. So I have already typed it. It's called insert last, and this function will be used to add new nodes to the linked list. So in here, let me explain it with this diagram in here. So the first thing that we do is we create a linked list, and then the first, as I said, that the first pointer will point to the first node in the linked list. So currently the link is not, this first node in here is not pointing to anything because I haven't created this linked list. So for now it's null. So I've created a pointer but it's not pointing to anything, just like we can see in here. I say first is equal to null, this one. Next, in here, if you look, the first node that we create in here, so the first time we create a node, we will have two pointers. One is, so whenever we are creating a new node, we will create it with the help of a pointer called temp. So temp will allocate memory inside the heap section. So you can see that whenever we are creating the nodes, these nodes, they reside inside the heap section of the memory. So we create these nodes with the help of a pointer temp, which will allocate memory inside the heap section. You will see it in the next couple minutes. So in here we can see that we are creating these two more pointers, and then we are saying temp is equal to new node. So whenever you are saying temp is equal to new node, it means that allocate space for the node inside the heap section. So in here, the first thing we did was we created a pointer temp and then another pointer called last. So we saw that the first time when we create a pointer, the first and the last, both of them will point to the first node. But then as we create more nodes, so the first will keep pointing to the first node inside the linked list. However, the last will move. So as we add in here, we can see that we added the second element, which is the last element. Again, we can see that the last is pointing to it. So let's say we add the third node in the linked list. So we can see that first is not moving anywhere. First is still pointing to the first one. However, when we created this new node, it is the last node. So this last will point to the last node. So we use this last pointer to point to the last node. So the first pointer will point to the first node and the last pointer will point to the last node. Temp, we use it, as I said in here, we use temp to create these nodes in here. So every time we create these nodes inside the heap section, we do it with the help of the temp pointer, because we are using this temp pointer to point to these nodes. So whenever we are creating space inside the heap section, we manipulate the data inside to it, or we refer to it, sorry, not refer to it, we access it with the help of pointers. So this temp pointer that we have created in here, we do it with the help of this pointer. So in here, I'm saying temp is equal to new node. What does it mean? It means that this node in here created. So it's a new node. So we can see that a node has two parts, right? The first part we saw was a data, and then the next one was a pointer that would point to itself. So in here, we can see that this has two parts, a node and the next part. So in here, this line creates this new node, and the pointer called temp will point to it. So for this one, I have said that first is pointing to it, but for now being know that temp is pointing to this first one in here. Now next in here, I said that the structure has two parts, right? One is the data, and then there is a pointer called next. So we say data should contain X. So whatever the user types in here, whatever argument the user passes, that integer will be stored inside the data part of it. So in here we can see that these structures, they have two parts. So in here there is a data part, and there is a pointer that will contain the address of it. So in here we say that the data section should contain a number, and then the next should contain null. So in here you can see that I'm saying temp data is equal to X, whatever the user types, and then the next should point to null. So this is like this in here. The first time you create a node, the first one, it will contain the number, and the next section will contain null, which means point to nothing. So this is what happens when you create it. Then we use this if else block. So we are saying if first is equal to null. So in here you can see that we said first is equal to null. It means that the first time we create a linked list, there won't be any node to it, right? It will be empty. So this first pointer and the last pointer, both of them will point to the temp in here. So the first time you run, you can see that it is null. So of course it will be null. So if it is null, what do? We are saying the first and last, they should both point to temp. So temp, as I said, is used to create a new node inside the memory. So this gets created with the help of temp, this gets created with the help of temp, this gets created with the help of temp. And we say that the first and last, so we can see that these two pointers that we create first and then the last. So these are two separate pointers. This is the first pointer and this is the last pointer. So you can say we say that we should both point to the first. So I said that the first pointer will point to the first node, and we can see that in here the first pointer will point to the first node and the last pointer will point to the last node. However, if we have only one node, both first and last should point to that node, right? So this is what it does. It points the first, it means that the first and last is both of them are pointing to the first node. Next, you're saying if it is the second node, what should we do? You're saying last next should point to temp. So whenever we created the first element inside the linked list or the first node, then the second time that we create, then we won't execute this if block in here. Then we will move to the else block, because then this condition will not be true. First won't be equal to null. First will contain the address. First will contain the address of this node in here. So it won't be empty. So first will point to the first node, then it won't be null. So if it's null, then we won't execute this block. Then we will execute this block in here. So we are saying last next should point to temp. So last, where is it pointing? Last is pointing to this node, right? And this has two sections, right? There is the data section, and then there is the next section, which is a pointer. We are saying its next should point to temp. So in here, its next should point to temp. So as we create a new element in here, we say that we created with the help of temp. So currently temp is referring to this node. So we are saying its next should contain the address. Since it's a type pointer, pointers can contain only addresses, right? So we are saying its pointer should equal to the address of the next one, the temp. So in here we can see that this 0x126 is equal to this. So this last next is containing the address of the second or the newly created node. So again, I will explain it one more time. So in here we are saying last next should point to temp. So whenever we create a new node, so it gets stored in here, right? The first time we created a node, it was in here. then we created this node, right? So when we create this node, of course, it will have a different address and it will have a different address. So you're saying its next should point to this node, right? Currently, its next is empty. We can see that in here, right? It's empty. However, its next should point to the second node. It should be like this, just like it is right now. You can see that it's pointing to the next node. So first, next is pointing to the second one. So however, for the very first time, first and last, since there's only one node inside the linked list, first and last, they are both pointing to the same node. This time in here, we are saying last next should point to temp. So we are saying its next port, which is this, should point to the next node. So in here, just like this is pointing to this port, that's exactly what we are doing. So in here, we can see that this 126 is the address of the second node. And then we say what? We say last is equal to temp. So what does it mean? It means when we created the first one, so first and last, they were both pointing to the same thing. We saw that in here. First is equal to temp and last is equal to temp. However, we are saying last. This time you're saying last is equal to temp. What does it do? It moves it. So for now being, you're both pointing to the same one. Then last will move to the last element, or in this case, which is the last and the second is the same. So we can see that last has moved to the second element. Then again, we call this function again. We added another number. So you can see that we calling it again. So this time when we call it again, what happens? Again, first it won't be equal to null. So this third element will be created inside the memory, this one in here. So as soon as it gets created, of course, it will have a data section, which will be equal to whatever user types, and its next will be null. Then we again check, is it first equal to null? No, it's not equal to null. So it means that this block won't get executed. The only time this block will get executed is when we create the linked list for the very first time. So this block will be executed. Again, it's the same. We are saying last next should equal to temp. So in here we can see that this previously was null. In here we can see that this is null, right? So now when we create a new element or a new node, so we can see that we are saying this should point in here to this area. So we can see that this last statement that we are saying last next is equal to temp. So this is exactly what it's doing. It's pointing this to the 19 in here, to the address of this one. So in here we can see that this is 134, right? So 134 is pointing the same as this one. So when we created this third node inside the memory, so it has an address, of course. All of them will have a unique address. So this time you're seeing, previously we saw that last was pointing to the second element. We are seeing last's next. So last's next is this. It's containing null. We are saying it should point to what? Temp. So temp will have its own address. So when we do that, we get this in here. So temp has address of 134. It gets stored in here. And then we have to move this pointer. So this pointer currently is moving to the second node. So we say last is equal to temp. So as soon as we execute this line, we can see that last then moves to the newly created node inside the memory. And then we finish it and then we display it with the help of this display function. So this display function, I will quickly go over it. I think I've also explained it in the previous tutorial. So it takes a pointer. A pointer is of type struct node. So in here we are giving it a pointer that is pointing to the first node inside the linked list. So in here you can see that we are saying first. So first, we can see that first is a pointer that points to the first element inside the linked list. Then it will know that once we get the address of the first one, so we can see that the second port of it will contain the address of the second node, and the second port of this node in here, it will contain the address of the third node. So once we find the first node, then it's easy for us to refer to these nodes in here. So let's go back in here. So the first thing we do is we give it a pointer, then we check, is it equal to null or not? So the first time when we give it, you can see that first is pointing to this. So it's not equal to null. So it's not equal to null. We are saying print cout p data. So what does it mean? We are saying, so this struct has two parts, right? The first one, this is the data part, and then this is a pointer, which is called next, right? So we are saying print the data part of it. So in here we can see that it will print. Then we are saying p is equal to p is next. So first we saw that we gave it per p, right? So this time you're saying p should equal to what? P is next. What is p is next? So in here, its next is pointing to this node in here. So we are saying p is equal to this. So it will of course have an address, right? So if it has an address, it's not equal to null, then again it will print the data 22. Then again we are saying p is equal to p next. Again it will point to this one in here, it's not equal to null, so it will print 19. Then we are saying p is equal to p's next, so of course p will be we can see that this time it's null. So this time when it's null, p is we are checking while p is not equal to null. So this time it will be equal to null, and we will move out of this while statement, and we print all the statements, and our program will be then executing. Again, I went quickly over it, watch my previous tutorial, and in that I've explained it again in very detail. So let's do a quick debug of it so that you guys could understand it even better. So we set a breakpoint in here, and I said let's run it first. So we run it, and now let's step into it. So we say step into. So when we step into it, you can see that the first time when we say insert last, we want to add 15 inside the linked list, right, inside the first node. So you can see that it calls this function, and then we are saying temp is equal to new node. So currently temp is not, so all these temp is null, last is null, and first is null. So all of them will not point to anything. So you can see that in here, data is empty, data is empty. But in here, as soon as I execute this statement, it will have an address, right? So in here you can see that as soon as we create the first node, it will have, it is created inside the heap section. So if it's in the memory, it will have an address. So in here, just like in here, we can see that this node has an address. So let's step into it. So when we say step into, now this temp in here that we have created, this has an address. Its address ends in 8BB0. Previously it was null, now it has an address. So it means that we have managed to create this block inside the memory. So we have reserved this many bytes, however many we need, which in this case, by the way, our structure is an integer and a pointer. So it's 4 bytes for this and probably 4 bytes for this. So it's probably 8 bytes. But again, it will differ from platform to platform. So for now being, we can, I think it's we can see that it's of size 8 bytes in here. So it will create that much, allocate that much space inside the heap section. Next, what we do, so it says data is equal to x. So currently we can see that data is equal to 0, and its next is pointing to some random address, which I don't think it really even exists because it's very different. We can see that from this address, right? So I don't think it exists inside this memory. It's not a valid address. So as soon as we execute this statement, so x currently is equal to 15. So you can see that we are passing 15 to this function, right? So as soon as we execute it, so data should be 15. So when we say step into, we can see that data is now equal to 15. This time we say next is equal to null. So for now being, next is has this random number in here. So when we say step into, we can see that its next is now pointing to null. So it means that we have managed to create this link, this node inside the memory. Now we have to say that the first pointer is pointing to this one, and the first and last, they should both, since this is the only link, sorry, this is the only node in our linked list, the first and last, both of them should point to this node. So this is what we are doing in this section in here. So we are saying is first equal to null. So we can see that first is equal to null, right? So if it's equal to null, it means what? Execute this block. What does this block do? So let me first debug and step into it. So we can see that it moves to this block in here. So we are saying first, which is equal to null, last again, which is equal to null, should contain the address of it, which contains 8BB0. So first and last, they are pointers. So pointers point to addresses, and the address of temp is ends in 8BB0. And in here we can also see that the address of temp is 8BB0. It's a very long address, but it ends in 8BB0. So we can see that for now being, they are both null. So we can see that their data is nothing, it's empty, but and they themselves, they are not pointing to anything, right? So as soon as we execute this one, so first should change from null to the address of this one in here. So in here we can see that its address of temp is equal to 8BB0. So now we can see that first is also pointing to the same space inside the memory. So we can see that first is equal to 8BB0. Previously it was null. And this temp, it has a data which is equal to 15, and its data is also equal to 15 because they are both pointing to the same location in memory. If they are pointing, then their values will of course be the same. Next, we are saying last is equal to temp. So last is equal to null. In here, we can see that last is equal to null. Its next is equal to null. And of course, if data is equal to empty. So as soon as we step into it, so we can see that last is also now has a data of 15. And we can see that it's also containing this address of 8BB0. So in here we can see that, and it contains the data 15, and it's pointing to the same address. So for now being, we can see that as soon as we create a new node inside the memory with the help of this temp pointer, so since it is the first node inside the link, we can see that the first and last, they are both pointing to this new node that we just created. So we can see that the addresses of first and last is the same as this temp. It's just like we did in here. So the first node that we create, first and last, these two pointers will point to the same node. So in here we can see that both of them are pointing to the same location. But then what we do next, we execute, we call this function again. So we're saying this time passing it 22. So again, let's step into. So we don't execute this else part because we have already executed the if port. Again, this time when we say execute, so this time it's calling it for 22. Step into, and then again we come to temp. So see why we do need this temp pointer. We need this temp pointer to create new nodes inside the heap section. First we created this, now we create this node inside the heap section. So we do it with the help of this temp pointer in here. So we are saying temp new node. So for now being, you can see that temp is pointing to 8BB0. So we can say that temp is currently pointing to this address. But as soon as we execute this line in here, it will create a new node. So it will create a new node inside the heap memory. So since all the addresses, all the nodes will have a different address, we should see that the address of it will change. So as soon as we execute it, we say step into. So now we can see that the temp's address has changed. It's 3E60. Previously we saw that first, last, and temp, they all had the same addresses. However, we can see that temp's address has changed. Temp is now pointing to 3E60. It means that now it has created this new section inside the heap, allocated this memory inside the heap section for the new node. So again, in here we are saying its data is equal to 0, and its next is containing this random number in here. So when we execute this line in here, which is saying temp data is equal to x, so when we say step into, so x was 22, right? So now we can see that its data is 22, and we are saying its next should be null. So when we create this new, it's null. So this random number should change. So when we do step into, we can see that this is containing null. So at this point, we are in this part of our memory. So we created this new node in here. So we have created a couple of nodes. So in here we can see that we created this previously. First and last was pointing to it. Now we created this. So now when we do it, we are saying is first is equal to null. So first is not equal to null. We can see that this has this address that ends in 8BB0. We can also see it in the debug section below. So we can see that first is equal to what? This address 8BB0. So if this address is equal to 8BB0, is it equal to null? No, it's not equal to null, which means that this couple of statements won't be executed. So we will move into the else block, this section in here. So as soon as we debug step into it, so we can see that we move inside this. We don't execute these couple of statements, we move in here. So this time it says last next is equal to temp. So what does it mean? So we can see that last next is currently pointing to null. So in here, when we created this one in here, so its next is pointing to null, and last is pointing to this node in here, and the next section of it, this next port, so this is the data port and this is the next port, it is null. So we say its next should point to temp. So temp has an address, right? So what we did, we created the first node, then we created the second node, right? We are saying this node, the second section of this node, which is called next, it's a pointer, so it should point to this node in here, right? Just like we are doing with the red line in here. So we are saying it should point to this. How do we do that? We are saying with the help of this statement in here. So its next is currently pointing to null. So as soon as we debug it, so this should change to the address of this new node that we created. This node has an address of 3E60. So as soon as, let me debug into it. So when I say step into, so now you can see that it has 3E60, which is the address of temp in here. So it means that this address, this is now pointing to the second node. So we can see that its first is now pointing to in here. Again, it's next, this null section, it should point to the next node. So in here we have created this next node. So we are saying it should be equal to temp. So this is temp, right? So it has an address of 126. So now we can see that it contains 126. So now we can see that this first pointer is pointing to this new node in here. However, the last is still pointing to the first node in here. We haven't changed last. We are only saying it should point to the section should point to the next node. It's next section. So in here we are saying last is equal to temp. So what does it mean? It means that it should change its location as well. So for now being last, we saw that first and last for now being they are pointing to the same location. It's just like in here. They are both pointing to the same address. However, as soon as we execute this statement in here, which is last is equal to temp, it means that this new memory that we have created, this new node that we created, last should move to this. So last should point to the new node that we just created, because last always points to the last node inside the element. So when we do that, when we step into it, so now you can see that last as the address of what? Temp. This is the new node that we just created. So now we managed to move last to the last node inside the element. So the last node is now pointing to the last node inside the linked list. Next, again, we move out of this loop. So if I step into, so again, this time we create insert last, and this time you're passing it 19. So let's do debug, and then we say step into, and again we are saying temp is equal to new node. So let's create it. So when we execute this statement, a new node will be created inside the heap section, just like this one in here. So this is the heap section. This is where the new node will be created. So let's execute this line. So as soon as we do that, you can see that the address again has changed. Previously it has the address of 3E60. Now we can see that the address has changed to 1130, and we can see that the data is empty and the next has some random number into it. This time you're saying x should equal 19 and its next should contain null. So for now being, let's step into it. So we can see that the data is equal to 19, and as soon as we execute this statement, it should also say null. So when we do that, we can see that its next is saying null. Now we are checking, is the first equal to null or not? No, first is not equal to null. First has an address. So in here we can see that first has an address, and when we hover over it, so we can see that again it has an address. So if it has an address, so it means that this block of memory, this block of instructions won't get executed. We will move to this else part. Again, what is it saying? It's saying last next should point to temp. So we can see that currently last is pointing to this node in here, right? It has two sections, a data section and a next section. So its next, I'm saying its next should point to the new node that we just created. So this is the new node that we just created, right? It has an address of 0x134. So as soon as we execute this line, so in here if we look at lasts, in here lasts next is null, right? So we are saying its next should contain the newly created node. So this is the newly created node 1130. So when I say debug step into, so now lasts next, sorry, I haven't step into, okay. So when I do that in here, we can see that now the last next is pointing to 1130, which is the new node that we just created, right? So in here, when we look at it, so this 134 is now inside the next part of it, of the second node in here. So now it means that this section is pointing to the new node that we just created. Then we say last is equal to temp. So even though its next is pointing to the new node, last is still pointing to the second node. So we are in this situation in here. Last is again currently pointing, even though we have created a new node, last is pointing to the second node. So in order to change it, we execute this line in here. We are saying last is equal to temp. So last should point to the newly created node. So as soon as we execute, so in here we can see that last is pointing to 3E60, and 3E60 is not the new node or the last node. The last node is the address of 1130. So when we execute this line, we say step into. So we can see that last this time last is pointing to what? 11 30. So it's the new node that we just created, right? Now it is pointing to the new node, and we can see that it contains 19, and its next is null. So in here we can see that it's next again this time, so we changed its address. In here we can see that now it's pointing to the second one, and the last node is now pointing to this node, and its next is null, right? So in here we can see that it says last next is equal to null. So now we know that last is pointing to the correct node in here, which is null. So this is how we know that we have reached the end of the linked list with the help of the null in here. So null means that we have reached the end of the linked list. Next, what we do is we display it. So again, let's step into. So in here we can see that we call this display function. Display function takes a pointer, which is the first. So in here, this display function takes the first, and first is pointing to the first node inside the linked list. So we are saying display is equal to first. So when we step into it, so the first time when we do it, it checks while p is equal to null. So p, so for now being, we say it's of type p, right? So we are saying p is equal to first, so because we are passing the first pointer in here. So is it equal to null? No, it's not equal to null. P has this address in here. So P has this address of what? 8BB0. So it's not equal to null, so it means that executed. In here we are saying cout P data. So we are saying show me or print the data section of it. So in here we can see that this memory to which this P is pointing to, it has two sections. One is data, and then this is next. So we are saying print the data part of it, or the data section of it. So in here, as soon as we say debug, step into, so it executes it, and we get 15 printed. 15 gets printed on a screen, and then we are saying P is equal to P is next, right? So P is equal to currently 8BB0. Then we are saying it is equal to P's next. So P has two ports, right? One was the data port, which we printed it in here, which contained 15. Now we are saying P is equal to what? P's next. What is P's next? P's next has this address, 3E60. So as soon as we execute this statement, P should say what? 3E60. For now being P is saying 8BB0. So let's say debug and then step into. So now we can see that P is equal to what? 3E60. So it means that our pointer has moved from this node to this node inside the memory. So in here, we do that. Again, we are checking, is P equal to null? No, P is not equal to null. P has this address, 3E60. P is pointing to this address of 3E60. So if it's not null, then execute, then we move inside the cout, right? So we can see that we move into cout. Again, we are saying print the data part of this memory in here. So P is pointing to this memory location, and it has two parts. One is data and one is the next. So its data part contains 22. So when we execute this line, we should have 22 printed in here. So when we say step into, we get 22 printed in here. So we can see that there is the data, and now 22 gets printed. Then we say P is equal to P is next. So P is currently pointing to 3E60. However, its next is pointing to 1130. So as soon as we execute this statement, P should change its address again. So now we can see that P is equal to 1130. So we are checking, is P equal to null? No, it's not equal to null. So again, we move inside the while loop, and then we are saying print the data section of it. So this memory location has a data section which contains 19. So as soon as we do that, we should get 19 beside this 22. So when we execute it, you can see that 19 gets executed in here. So 19 gets printed. Then we are saying P is equal to P next. So the next section of this pointer, it's null. So we are saying P should equal to null. So for now being P contains this. However, as soon as we say P is equal to P next, it should change. So now P, you can see that it has changed. Now P is equal to null. So in here we are checking P is equal to null. So in here, and this while statement, we say while P is not equal to null. So P is equal to null, right? Because P is null. So if it means that if it's not equal to null, execute these lines. But if it is equal to null, then move out of this while loop. So when we do a step into, we move out of this while loop, and our program gets stop running. So this is it for this one, guys. This is how you can create a function to insert a link, insert inside the linked list. So let me treat this breakpoint product. Okay, stop running it. Let's run it one more time. So in here we can see that this three numbers that we executed, sorry, these three nodes that we created, we print all of them. So this is how you can create a function to insert new nodes inside the linked list, to insert at the end of the linked list. In the next couple of tutorials, I will show you guys how to create a node at the beginning of a linked list, or at the middle of the linked list, or at a particular index that you want. But for this tutorial, this is it, guys. It has been a very long one. Now, if you have any questions, suggestions, or recommendations, feel free to put it in the comment section below. And if you found this tutorial useful, make sure to share it with your friends, and I will see you guys in the next one.